So let's go ahead and talk about the problem of the day. Remember to try your best to compare your work to what we talk about together and answer the questions I ask out loud. If you want to adjust or improve your work as we talk, that's great. Go for it. There's a lot of ways that you might have represented this problem. Some of you probably drew a picture of the rectangle for the wall with an area of 28 feet, width of 4 feet, and an unknown length. That's great. Some of you might have also represented using the area formula, right? We know area equals length times width. So 28 equals length, which is our unknown, times 4, which is our width. Okay, how could we use the grid paper that we had on that draw it slide to help us solve this problem? Say it out loud. Yeah, we could draw a rectangle with a width of 4. 1, 2, 3, 4. And then we could just start extending the length until we get to an area of 28 feet. So this would be 4 feet, 8, 12, 16, 20, 24, 28 square feet. I could check by counting all my squares. This is 4, this is a length of 7. 4 times 7 is going to be 28 square feet. Yeah, that would totally work. But what if we didn't have grid paper? How could we solve then? Say it out loud. Yeah, we could use the area formula to help us. And one way to use the area formula to help us would be to use division. Okay, how would it work to use division with the area formula to find our missing length? Go ahead and say it out loud. Yeah, we know that area equals length times width. So we know that 28, which is the area, equals the length times 4. So we could use division to solve multiplication factors with a missing factor. Excuse me, we could use division to solve multiplication problems with a missing factor. If the area is 28 and one side is 4, so area 28, right, we have length times 4, then we could divide 28 by 4 to find the missing side. We could take 28 divided by 4, and that would equal our length. Why can we use division to find missing factors in multiplication problems? Say it out loud. Right. In multiplication, the factors are the groups and the amount in each group, and the product is the total. If we know the total and the groups or the amount in each group, then we could think about this as division. Right? That's what division is. Taking a total that's being divided into equal groups and figuring out the number of groups or the amount in each group. So 28 divided by 4, that equals 7. So the missing length would be 7 feet. Great, same answer we got with our grid here. Okay, what did we just do to find that missing length? Say it out loud. I bet you said something like this. Read it with me. If we know the area and one side length, we can divide to find the missing side length. Area equals length times width, so area divided by length equals width, or what we did was area divided by width equals length. Okay, great. And there's actually another way that we could use the area formula to help us. How could we use the area formula to find the missing length without dividing? Say it out loud. Yeah, we could just use known facts. We know that 28 equals length times 4. So we could think about a known fact to help us solve that. We could think 28 equals what times 4? What times 4 equals 28? Say it out loud. Yeah, 7. So 28 equals 7 times 4. Again, our missing length is 7 feet. How did we just figure out that missing side? Say it out loud. Yeah, we used known facts. We thought blank times 4 is going to equal 28. Okay, go ahead and read this last key point with me. If we know the area and one side length, we can hop down here, use known facts, and think blank times length equals area, or blank times width equals area. Wow, really interesting. Lots of ways to tackle these problems. All right, go ahead and click on the arrow to move to the next slide.